Hello friends, today I will discuss the numerical problems on pitch factor, distribution factor and the generated EMF in the alternator. So let me take a first question. Find a distribution factor, that is also called breadth factor, for a alternator having 9 slots per pole for the following cases and comment on the results. A is a 3-phase winding with 120 degrees phase group. B. A 3-phase winding with 60 degrees phase group. Solution for this is like this. First, the number of slots per pole given as 9 and the solid angle, slot angle is given by beta, and that is nothing but 180 divided by slots per pole, that is 180 by 9, that is 20 degrees. Next, since the phase group occupies in the first case is 120 degrees, the number of slots per pole per phase m becomes phase group angle divided by the slot angle, that is beta. So phase group angle is nothing but 120 degrees divided by 20. So then we get here m is equal to 6. And having known the distribution factor formula, that is sine m beta by 2 divided by m into sine beta by 2. Substituting these values here, that is sine into 6 into 20 divided by 2 divided by 6 into sine 20 by 2. And after simplification, the distribution factor Kd comes as 0.831, which is less than 1. Next, second case. If the phase group occupies 60 degrees, in that case, the number of slots per pole per phase is given by phase group angle divided by the slot angle. That is nothing but 60 divided by 20, that is nothing but 3. Now the distribution factor Kd can be written as again sine m beta by 2 divided by m into sine beta by 2. So that is sine of m is now it is 3. So into beta is already calculated as 20 divided by 2 divided by 3 into sine beta means 20 divided by 2 here. So after simplification, Kd becoming 0.96. So when the distribution factor is 0.831, the generated EMF will be less because 4.44 phi AFT and distribution factor, that is Kd. So when the Kd value is less, automatically generated EMF also less. If the Kd increases, then the value of generated EMF per phase also increases. So easy reduces with reduction in the Kd. Let me take another problem. Find the RMS value of phase voltage. Phase voltage means generated voltage here. For a 3-phase 50 Hz 20 pole 180 slot synchronous generator having a single layer winding with full pitch coils. The coils being connected in 60 degrees phase groups, each slot having 6 conductors. All the coils are connected in series. Flux per pole given as 0.25 Webers. So to get the generated EMF per phase, the formula is nothing but 4.44 kW, that is Kd into Kp into phi next T phase into frequency f. So for that, first try the given data, that is P number of poles are given as 20 and the number of slots are given as 180 and the number of frequency of the supply is 50 Hz. So from this first step we can calculate number of slots per pole, that is 180 divided by 20, that is 9 will come. Then slot angle beta is nothing but 180 degrees divided by slots per pole. The slots per pole is already calculated as 9. Substitute that here. The beta is equal to 180 by 9, that is 20 degrees. Next, step 3, the number of slots per pole per phase, that is represented by M, is equal to the number of slots per pole is nothing but 9 by number of phases, that is nothing but 3. So then M becomes 3. So now the distribution factor using this M value and beta, they get like this. KD is equal to sine M beta by 2 divided by M sine beta by 2 is equal to sine of 3 into 20 divided by 2 and divided by 3 into sine 20 by 2, that is 0.96. Since it is a single layer winding, total conductors Z is nothing but number of slots into number of conductors per slot. Number of conductors per slot given as 6 and the number of slots are also given as 180. Then the total number of conductors will come as 1080 and the number of conductors per phase should be divided by 3 because it is a 3-phase system. So then we get here 360 conductors per phase. But for getting the induced EMF or generated EMF, only per phase turns are used. So since the two conductors forms the turn, so then the number of turns per phase is equal to number of conductors per phase divided by 2, that is equal to 180. So having known the number of turns and the flux and the distribution factor frequency, then it is possible to calculate generated EMF as Eg is equal to 4.44 kd into kp into phi into f into t. Here 4.44 into kd means distribution factor, which is just calculated as 0.96, and pitch factor, because it is a full pitched winding, the pitch factor becomes 1, and the flux given as 0.025 Webers, and frequency is also given as 50 Hz, and the number of turns per phase calculated as 180. After simplification, then the voltage will become 959 volts. So let me summarize the numericals covered here. So in the first case, the case is that the distribution factor is supposed to be calculated. For that the phase group is given, and from the given data we should calculate first what is beta, that is slot angle, and after that we should also calculate for the different cases the number of slots per pole per phase, that is M, that can be calculated using the formula called phase group angle divided by beta. And after knowing M and beta, then it is possible to get the distribution factor using the formula sin m beta by 2 divided by m into sin beta by 2. Similarly, in the next problem we have seen that on similar lines the distribution factor is calculated, and we found that the distribution factor is increased. If the distribution factor is more, means automatically the induced voltage from the generator per phase is more. If the distribution factor is less, means automatically the generated EMF per phase is also less. And in the next case, similar to the previous case, it's given the data, and here also we have calculated what is beta, and it is given that it is a full pitched winding. For a full pitched winding, the pitch factor is 1, and with the given data we have calculated what is the beta and also what is the distribution factor. After knowing the distribution factor and after calculating the number of turns per phase, we have calculated what is the generated voltage with the formula, that is 4.44 kW and phi f and number of turns per phase.